start out in a new chapter in which notice that the name of the lesson has to do with rational numbers as exponents. And let's go back and look at some of the ideas that we've done. 3 squared we know is equal to 9. 3 to the 0 power we have defined as being equal to the number 1. And 3 to the negative 1 power we have said is equal to 1/3. And I think, even though perhaps you are familiar with it, I think perhaps it's worth asking the question, what do we mean by 3, say, to the 1/2 power? In which notice here that our exponents were a positive integer, the number 0, a negative integer, and now, for the first time, let's look at a fraction in that exponent. Well, if we were to ask ourselves whether or not some of the basic properties that we have already been dealing with still hold true, let's take this number and square it, whatever it happens to be. And if we were to do so, we have there, now here we have 1/2 raised to the, that is 3 to the 1/2 power all squared. And one of our properties that we had that held true with respect to, say, positive integers told us that we must do what there? We must, what? We have here 3 to the 1/2 all squared. What must we do? What should we do with those exponents but to, Don?
Multiply.
But to multiply them, we have 1/2 times 2, which we know is the number 1, and this turns out to be the number 3. Well, but we've already decided some time ago, we have already defined that the square root of 3 all squared is equal to what number? This is equal to 3. So I think that you were forced into the number to say that 3 to the 1/2 power then is going to be equal to what? The square root of 3. And in fact, if we then were to take some number, say b raised to the 1/r power, I think that you would like to define this as being equal to what? And how about the, Doug?
R root of b.
The rth root of b. Okay. Now what I'd like to do is to come back and look at these numbers and see exactly what values that we can have for b and r. But let's just continue this discussion for a minute. Suppose we had, say, 3 raised to the 2/3 power. And you look at that and you say, well, I think I may think of this as 3 raised to the 1/3 power all squared, using our same theorem with respect to exponents, and now extending it when we have here the numbers such as 1/3 and 3 to the 1/3 power. We would like to say, just from our definition, Don,
Cube root of 3.
there we have the cube root of 3, and then it would be this number squared. That would be a name for 3 raised to the 2/3 power. And in fact, if we then were to say b raised to the p/r power, and what then would you like to say that this is equal to? But what? Is anybody just looking at it, Bill?
The R root of b all raised to the p power.
The rth root of b all raised to the p power. Now, in fact, let's include this as a definition. And looking at that statement again on the left-hand side, I think that you would look at that and say, well, I may write this as b raised to the p all raised to the 1/r power. Is that right? And now, using our definition again, this may be then written as what? And here we have, and how may we say that, Brenda?
The rth root
The rth root
of b to the p.
of b raised to the p power. And looking at this statement and what we have here in this statement, I think then we can conclude that the rth root of b all raised to the p power is then going to be the same as what? The rth root of b to the p power. All right? Well, let's call this our first idea, and then what I'd like to do is to come back and look at these numbers and see exactly what values that we can have for them. For example, suppose we were then to go back to positive integers. Well, we've already said what is meant by 3 squared, and how about a number such as negative 3 squared? We certainly know that this is well defined. And how about a number such as the square root of 3 raised to the 2 power? This certainly is well defined. Have we said anything about 0 raised to the 2 power? And we know that this is equal to what number? 0. This is equal to 0. So whenever we write b to the n power, all right, and notice here in our exponent we happen to have in each case a positive integer, And when we have our number in the pattern of b to the n, and n is a positive integer or a natural number, what value can b take on? And what kind of a number can b have? B can be certainly what? Do you think it can be any real number? All right. Can we have, I think I've taken just about every example that we can have here. 3, negative 3, a negative number. The square root of 3, we can have, say, 1/2 squared. And I think that you will agree that this statement is true. Now, as soon as we then try to extend our exponents, let's say, into the set of negative integers, 3 to the negative 1/2 power, or 3 to the negative 2 power, rather, we may think of this as what? This we know as what? 1 over 3 squared, which we have called 1/9. Now, suppose then we were to take, say, 0 raised to the negative 2 power. And using our same statement as we've had before, you would like to say that this is 1 over 0 raised to the positive 2 power, but of course you know that this does not belong to the set of real numbers. This one is not defined. So then if we were to look at, say, b to the n power, in which we would like to have n over the set of integers, what restriction must we place on the number b? B cannot be what number, Don?
0.
B in this case cannot be equal to the number 0. Okay? Well, let's then look at what we're leading up to here. Suppose we had, say, 3 raised to the 1/2 power, in which now we're looking at this exponent of, say, a number such as 1/2. And if we then had, say, a number such as negative 3 raised to the 1/2 power, you would then, if you were to use the definition of what we've just said, this then is going to be equal to, you would have to say that it's equal to what number, Bill?
The square root of negative 3.
The square root of negative 3, and if we want to be in the set of real numbers, what's our conclusion about the square root of negative 3? We know that that number is what?
Not a real number.
It's not a real number. So if we then had b raised to the n power, and we now have n, say, well, let me write it as 1 over n in the pattern that we have been writing it, in which we have here n, say, is a natural number. What must we have true for this number b? And what kind of number can b not be equal to? And from what we have here in our example, it looks like b cannot be, Tim?
Negative number.
B cannot be negative. So in this case, let's put our restriction that b is greater than 0. Okay? Now, in fact, I think we can define a number such as 0 to the 1/2 power as being equal to what number? You would like to say that this is equal to 0 itself. And I think we may define this as 0 to the, say, 1 over r power is then going to be the number 0 itself. Well, let's carry this one step further. Suppose we had a number such as, let's take, again, negative 3 raised to the, let's say to the 3/2 power. And again, looking at this, you would like to say that this is the square root of negative 3 cubed. Is that right? And I think then you've got difficulties again in which this would not be. Well, if we then were to say that this is equal to what? The square root of negative 3 cubed, this is not inside the set of real numbers. Is that right? It's not a real number. So then, if we had b raised to the, say, p over r power, all right, what then can we say about these various numbers? Well, r, which is going to be the index here, the root, has to be what kind of a number? R always must be what? R must be a natural number, right? We have not defined a negative number here, such as we don't even know how to say it. Now, what kind of number can p be? If we had then, say b raised to the, let's say, negative 3 raised to the negative 3/2 power. In fact, let's write that down. Negative 3 raised to the negative 3/2 power. I think you would have to write this as negative 3 raised to the what? To the 1/2 power, all raised to the negative 3. Is that right? But we've already said that this number is not inside the set of rational numbers. What number can we say that p can be? P can be what kind of number here? Well, certainly an integer, and again, what kind of number must b be in order to make this one, for example, a real number? And b has to be what? A positive number. Again, b then must be greater than 0. There's you see, it's a question as to having your basic properties that you have already stated with respect to the other set of numbers still hold true. For example, suppose we had a number such as -8 raised to the 1/3 power. I think that one would like to say that this is equal to what? You'd like to say that this is equal to the cube root of -8. Now you've already said what the cube root of -8 is. You know that that's equal to a number -2. Now, let's look at this number, -8 raised to the 1/3. And now if we want all of our properties that we've already stated hold true with respect to this number, such as raising this to the 2/2 power, all right, here we have a product of a power, which we would like to do what with those exponents? We would like to multiply them, and that then gives us -8 raised to the, there's 1/3 times 2/2, which is what number? To the 2/6 power. And as soon as we have that, then looking at -8 raised to the 2/6 power, you're dealing with the 6th root of a -8 squared. Is that right? And so therefore, I think in this case we have a -8 to the 1/3 power would not be the same as -8 raised to the 2/6 power. Even though 1/3 is the same as 2/6, and -8 certainly is the same as -8. So this statement would not hold true. And in order to avoid problems like this, we'll just arbitrarily decide that our number b, the base number here, then is going to be a number which is greater than 0. Okay? And we then can think in terms of this definition and these restrictions on our numbers for b and p and r. All right? Well, let's look at one or two examples of these. Suppose we were to have let's take a rather simple problem. 4 raised to the 1/3 power times x times y raised to the -2/3 power. And let's see what we may say about this. And let's write this with radicals, if possible. Well, the 4 raised to the 1/3 power we may write as what? This is the cube root of 4 times, and this is now simply the number x. And now here we have y raised to the -2/3 power. I think you would have to say is y raised to the positive, that is to the 1/3 power, all to the -2. Is that right? And looking at that, there's the cube root of 4 times x. Now here we have y to the 1/3 power, which is what? That's the cube root of y, all raised to the -2 power. I don't think it's necessary to put in every step here, but let's see how many we have to include. And here now, this number to the -2 power is what? 1 over the cube root of y, all squared. Is that right? And now looking at that, is the cube root of 4 times x, and now here we may think of this as what? 1 over the cube root of y squared. Is that right? And 1 over the cube root of y squared. In fact, let's rationalize this number right here. And what then is a name for the number 1 that we would like to write? And Peter?
Cube root of y over the cube root of y.
The cube root of y over the cube root of y then is going to give us in the denominator what number? But y. And so here we have, let's rewrite this as what? X over y times the cube root of what? Here we have the cube root of 4 times, and we still have there the cube root of y, which we may write as what? The cube root of 4y. And of course the restriction that we want to put on y is what? That y must be what kind of a number? And Malcolm? A positive number. And is that what we would like to say?
Non-negative.
A non-negative number.
It can't be 0.
Can't be 0, right? So y then is going to be greater than 0. Let's look at a second example. Suppose we had a number such as the cube root of the square root of 27. And see what we may say about this. Well, let's see now, the cube root, now let's look at 27. This is the square root of 27, which we may think of as what? That's 27 raised to the 1/2 power, is that right? And now here we have 27 to the half, and now here's the cube root of all of that, so we may think of this as 27 to the 1/2 power, all raised to the what? To the 1/3 power, and this then is 27 raised to the 1/6 power. But another name for 27 is 3 cubed, all raised to the 1/6 power. And now here we have a name for this, which is what? 3 raised to the 3/6, which is 1/2. And of course, then this may be written as the square root of 3. So we started out with perhaps a rather messy looking number, the cube root of the square root of 27, and the most simple name for that is the square root of 3. Well, let's look at another example. Suppose we had a rather straightforward equation, but in this case we have as the exponent a negative 3/4 power is then equal to 127. All right? Now, again, looking at this, let's decide to multiply, or let's raise both sides of this equation to some power. And what number would you like to raise x raised to the negative 3/4 power in order to have simply the number x here? And what then may we say about that? But Doug?
To the negative 4/3.
Raised to the negative 4/3 power in order to then give us here on the left-hand side the number x. Is that right? And so we then must multiply or raise 1/27 raised to the what power? To the negative 4/3. Well, 1/27 to the negative 4/3 is what number? It's 27 raised to the what? To the positive 4/3. Is that right? And now, using our definition, we may write this as what? This is then what? The cube root of, let's write this as the cube root of 27 all raised to the 4th power. I think it's a lot easier to look at it this way than the cube root of 27 to the 4th, because that's a rather large number. The cube root of 27 is a smaller number, which is what? 3. And then that number 3 to the 4th power is equal to what? 81. That then is equal to 81, and that then is the solution, the root then of this equation, x to the negative 3/4 power is equal to 127. Well, let me give you your homework assignment, and you can practice on some of these problems. This will be